Hello everyone. Today is 23rd of December, but we are going to solve two more days that I've missed, which are 22nd Monkey Market and the 23rd of December, 23rd day of Advent of Code, and we're going to solve it with AI models. Just to remind you, previously, on the previous day, the 21st day, none of the models have solved the even the first part of the task. It was an interesting task. We've read it all, only the first part, but no, again, none of the models, even O1 Pro, didn't solve. So let's see if this task will be easier for them. And yeah, just remind, this is an experiment of testing of AI models, how they are to measure their performance in terms of programming tasks, which involve algorithms. A lot of pathfinding on this year was involved. So yeah, seems like AI models struggle with pathfinding, where there is a complex conditions. So yeah, seems like today it's not a pathfinding thing, and we'll see what this is about in a minute.
As you're all teleported deep into the jungle, a monkey steals the historian's device. You'll need to get it back while the historians are looking for the chief. The monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. Your only option is to buy bananas on the monkey exchange market.
Nothing is clear.
You aren't sure how the monkey exchange market works, but one of the historians senses trouble and comes over to help. Apparently, they've been studying these monkeys for a while and have deciphered their secrets. Today, the market is full of monkeys buying good hiding spots. Fortunately, because of the time you recently spent in this jungle, you know lots of good hiding spots you can sell. If you sell enough hiding spots, you should be able to get enough bananas to buy the device back. On the market, the buyers seem to use random prices, but their prices are actually only pseudo-random. If you know the secret of how they pick their prices, you can wait for the perfect time to sell.
Oh, nice. So we need to find out the algorithm that that pseudo-random digits or numbers are being generated.
The part about secrets is literal, the historian explains. Each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. Calculate the result of multiplying the secret number by 64. Then, mix this result into the secret number. Finally, prune the secret number. Calculate the result of dividing the secret number by 32. Round the result down to the nearest integer. Then, mix this result into the secret number. Finally, prune the secret number. Calculate the result of multiplying the secret number by 248. Then mix this result into the secret number. Finally, prune the secret number.
What does it mean with mix the result? How do you mix? Alright, we have another instruction for that exactly.
Each step of the above process involves mixing and pruning. To mix a value into the secret number, calculate the bitwise XOR of the given value and the secret number. Then the secret number becomes the result of that operation. If the secret number is 42 and you were to mix 15 into the secret number would become 37. To prune the secret number, calculate the value of the secret number modulo 1677216. Then the secret number becomes the result of that operation. If the secret number is 1000 and you were to prune the secret number would become 16113920. After this process completes, the buyer is left with the next secret number in the sequence. The buyer can repeat this process as many times as necessary to produce more secret numbers.
Okay, so we have a list of instructions that we need to follow. Calculate the result of multiplying the secret number, dividing the secret number, prune, and multiplying the secret number. Sometimes we need to prune it, and sometimes we need to prune it again, and then mix it. And we have two instructions: how to mix and how to prune. Seems like, yeah, there are some other instructions, but seems like it should be less complicated than the previous one, because it's not a pathfinding when you need to like. But even in the previous task, I think that could be approached some way, some nice approach. But here we got just a list of instructions that we need to follow. It could be hard to like comprehend what does it mean to prune, what does it mean like to prune here. I didn't get this. I need to read it like 5 more times probably and to understand what does it mean. But in any case, oh no, I understand. So it's just this number. Never mind. Yeah. So we have those instructions, and probably AI is able to understand this faster and better than me. So yeah, let's see. After the process completes, the buyer is left with the next secret number in sequence. The buyer can repeat this process as many times as necessary to produce more secret numbers. So if a buyer has a secret number of 1, 2, 3, then the buyer's next 10 secret numbers would be these numbers. Let's see the rest.
Each buyer uses their own secret number when choosing their price, so it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number of each buyer, your puzzle input. For example,
okay, so those are the initial secret numbers of each buyer.
This list describes the initial secret number of 4 different secret hiding spot buyers on the Monkey Exchange market. If you can simulate secret numbers from each buyer, you'll be able to predict all of their future prices. In a single day, buyers each have time to generate 2,000 new secret numbers. In this example, for each buyer, their initial secret number and the 2,000th new secret number they would generate are
those numbers. Adding up the 2,000th new secret number for each buyer produces this number. So adding up all of them, summing them up. So what's our puzzle input? Okay, so we have 1,000 numbers, 1,000 different numbers that we need to place in our cursor. It's which day? 22. So day 22. By the way, I need to know solution found for 21. And let's go to the 22. Let's place the input. Oh no, that's not 1,000, but 2,396 numbers. So day 22, day 22 solutions. Then we have this description. I think it should be easier for the models. I will be trying 01, not 01 Pro now, because it's just it just takes too much time. Okay, so what was our prompt again? Okay, so here is the task. Here's the template. So template for code, and then description, what we're doing, and then and then the rest of the logic, the rest of the prompt, except for the latest points. So implement the logic. So I'm just prompting it to solve the first part, the first task, writing full code, full working solution, not an example, without placeholders, full code that I can run and solve with my puzzle input. Implement the logic. Because I've been seeing this so many times that O1 just goes and just writes, here's the, because we already have the example inputs and the example output, the results. Here's what we got, and just giving me a placeholder. So okay, so pretty simple. I'm not sure if that's the correct solution. It's looking so small, but it could be. It really could be. Yeah. Okay. So we are on day 22, and let's run Python 01 pi. And alright, we have a number. Let's submit and get our first gold star. Perfect. So let's just see what the logic was about. We have a modulo, some module. Why is that? So is it? Okay, so we have always this module. Step 1, x secret multiplied by 64, then secret was it in the description? Multiplying, then mix result into the secret number, print the secret number. Multiplying the secret number by 64. Yeah, just 64, secret number by 64, then by 64, then what? Then this result into the secret number. Mix. Finally, so to mix value the secret number, calculate bitwise XOR of the given value and the secret number. So secret. So apparently this is an XOR operation. I didn't know. Okay. Then the secret number becomes the result of the operation. If the secret number is 42 and you are mixed secret number, okay. So then calculate. Where's module? To prune the secret number. So okay. So then mix the result and then prune the secret number. And the pruning is calculate the value of secret number modulo. Then the secret number becomes the result of this of that operation. So the secret, we get the module. What do we do? Calculate secret number module. What was that? Calculating the secret number module. It's multiplying by then result. Then mix this result. Okay, so we firstly mix. Apparently this is mixing, this is module. And step 2, dividing by 32, divided by 22, then mixing and module. Then step 3, multiplying by 2048, then mix and then prune. Okay. Yeah, straightforward. Okay. What's the second part? Well, let's see.
Of course, the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyer offers are just the ones digit of each of their secret numbers. So if a buyer starts with a secret number of 123, that buyer's first 10 prices would be.
So if a buyer starts with a number to 123, that buyer's first 10 prices would be. Okay, so 3, 0, 6. So the last one, one digit of each. Okay, just the last one probably. Let's go again.
This price is the number of bananas that buyer is offering in exchange for your information about a new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little, but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Unfortunately, the monkey only knows how to decide when to sell by looking at the changes in price. Specifically, the monkey will only look for a specific sequence of 4 consecutive changes in price, then immediately sell when it sees that sequence. So if a buyer starts with a secret number of 123, that buyer's first 10 secret numbers, prices, and the associated changes would be.
So apparently we now track the changes. We go for all the secret numbers, we get the last digit, and then we see what changes are made. So 3 minus 3 will be 0, plus 6 will be 6, minus 1 will be 5. So we need to look for a sequence of 4 consecutive changes in price, then immediately sell when it sees that sequence. Okay, so understood. So this sequence should, at some point, the sequence should be repeated, and if it's repeated, so probably we need to find the lowest possible price, isn't it?
Note that the first price has no associated change because there was no previous price to compare it with. In this short example, within just these first few prices, the highest price will be 6, so it would be nice to give the monkey instructions that would make it sell at that time. The first 6 occurs after only 2 changes, so there's no way to instruct the monkey to sell then, but the second 6 occurs after the changes. 1, channel 1 through 2. So, if you gave the monkey that sequence of changes, it would wait until the first time it sees that sequence, and then immediately sell your hiding spot information at the current price, winning you 6 bananas. Each buyer only wants to buy 1 hiding spot, so after the hiding spot is sold, the monkey will move on to the next buyer. If the monkey never hears that sequence of price changes from a buyer, the monkey will never sell and will instead just move on to the next buyer.
Okay, so we need to sell with the highest price. I've confused that part.
Worse, you can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. You're going to need as many bananas as possible, so you'll need to determine which sequence of 4 price changes will cause the monkey to get you the most bananas overall. Each buyer is going to generate 2,000 secret numbers after their initial secret number, so for each buyer, you'll have 2,000 price changes in which your sequence can occur. Suppose the initial secret number of each buyer is.
Okay.
There are many sequences of 4 price changes you could tell the monkey, but for these 4 buyers, the sequence that will get you the most bananas is 2 power 1, 1003. Using that sequence, the monkey will make the following sales. For the buyer with an initial secret number of 1, changes 2 power 1, 1003 first occur when the price is 7. For the buyer with initial secret 2, changes 2 power 1, 1003 first occur when the price is 7. For the buyer with initial secret 3, the change sequence 2 power 1, 103 does not occur in the first 2,000 changes. For the buyer starting with 2024, changes 2 power 1, 103 first occur when the price is 9.
Okay, so we have only one algorithm that does not change to all of the monkeys. Okay.
So by asking the monkey to sell, the first time each buyer's prices go down 2, then up 1, then down 1, then up 3, you would get 23, 7 plus 7 plus 9 bananas. Figure out the best sequence to tell the monkey so that by looking for that same sequence of changes in every buyer's future prices, you get the most bananas in total. What is the most bananas you can get?
Okay. Where is that? Okay, so O1. Let's go with O1 Pro. Now let's find the part when we are saying our answer for the first part. Okay, let's go to the prompt. So the task, both parts, using the template, write for working solution, blah blah blah. Okay. Oh no. Yeah. Send O1 Pro mode, send. Okay. And while we're waiting, while it's thinking, we are going to prompt all other models. I think they reasonably can handle this. So O1 Mini, let's go with normal mode. Let's prompt our DeepSeek new chat with enabled deep think. Then we are going to prompt what's that? Sonnet, start new chat, Sonnet, also Haiku, prompt start, also Gemini 1206. Also, what's next? What's else? Yeah, seems like that's the first part. Okay, let's see. What do we have? We have something. Yeah, we have generate new next secret. That seems like a correct. Yeah, that seems like a correct thing to do. Then part 2. What was the part 1? Part 1. Why? Part 1. Okay, for initial secret in data. Okay, part 2. Okay, I see. So this is the solution for the first part. Get price changes. Part 2. What's that part? Part 2. What's that? Does it do? Prices append. Changes append. Scene sequences. Okay, let's see. So we have something from O1 Mini. We have something from DeepSeek. Let's copy that. DeepSeek. Yeah, the input is correct. Next secret, temp 2, new secret, that's correct. Get 2000 secret, that's correct. Part 1, generate prices, compute changes. And I like the structure of this code. This is a definitely readable one. While I'm not sure if that's the correct one. Okay, let's go with the next. What's that? This is Claude 3.5 Sonnet. Not copying that part. Okay, code. Sonnet. Let's paste it. Okay. Now it's Haiku. Okay, so it's front-end issue. Again, okay, we have something from this. Yeah, it seems like it's correct. Yeah, okay, so it's correct code. Like, I mean, working. Haiku. Shouldn't be any errors. Yeah, there are none. Okay, Gemini. Let's see. Let's paste. Okay. Okay, now Gemini has been correctly using the input name. So what's next? What's next? Okay, so O1 Pro is still thinking, no problem. Let's run GPT-4o. Let's select GPT-4o Mini. GPT-4o Mini. Let's run it in normal mode. After it finishes, we are going to run GPT-4o. Okay, could be a correct one. Who knows? And another composer, GPT-4o. GPT-4o, normal mode. Right, and O1 Pro is still thinking, no problem. Yeah, okay, read input, evolve secret number. Generate secret numbers. Part 1. Calculate prices. Find best sequence. Hey, why did you stop? Why did you stop? It's probably some issue with the streaming. I think I'll need to like rerun the script. Go again. Go again. Do we have enough? Yeah, we have something. So, what will part 2 do? What will it do in part 2? So we'll start it in a dictionary for each buyer. Dictionary changes. Dictionary for changes. Here list price. Okay, we'll combine it all across all the buyers in a global dictionary, summon prices for each pattern. Okay, so seems like something correct. Okay, we have something from GPT-4o, and we have an answer from GPT-4o Mini, GPT-O1 Pro, and let's run them all. So let's start from O1. We have the correct answer for the first one. And we have an answer for the second. Why is it so small? Hopefully, okay, so most bananas, okay. And this is a correct answer. Perfect. Okay, so wow, it's so nice. It's so nice. Okay, let's see. Yeah, we've already pasted all the parts. Let's run other O1 Mini. Correct one. And part 2 is incorrect one, but really close. Really close. Okay, let's write down. So, success. And success. Then O1 Mini, success and failed. Then let's run as it follows. GPT-4o Mini, a correct answer, success. Yeah. So like you see, that's not a tricky problem. The first part was not tricky even for GPT-4o Mini, because it's just about sequence of rules, and it could be just complicated for a person to understand what the task is about, how to actually approach it. But then after you do, it's a simple thing to implement. But when it comes to pathfinding, the models really struggle. Not just basic pathfinding, but with complex conditions. It's still thinking. I'm not sure I'm going to allow it to think much more time, so I'll consider this as fail. For the second part, let's run the next model, which is Claude 3.5 IQ. Claude 3.5 IQ. Okay, we have an answer for the first one, which is a correct one. Success, yeah. And let's not wait for other models. Where we are, okay. Python, GPT-4o. Let's see. Wow, it is incorrect. GPT-4o failed. That's unexpected because GPT-4o Mini solved it, but then 4o didn't. Interesting. Okay, let's see the sonnet. Claude 3.5 sonnet. I'm mostly sure, yeah, this is a correct one. Success for sonnet for the first part. Let's see if it's able to solve the second. Yeah, let's run in parallel another model as well, which is O1 Mini. Python, like Python O1 Mini. I think we've already run this. Success for the first part is correct. Second part, actually don't remember what was the number. I think it's correct. 2242. And no, it's incorrect, but yeah, correct for the first part. Okay, so O1 Mini was really close, but not as close as it should be. Now Gemini. Yeah, the correct answer for the first one. And for the second, if we're going to wait for a long time, we'll consider it as fail. And we have also a DeepSeek model. These were tried, by the way. I don't remember now. Yeah, okay. So I'll stop for Claude 3.5 IQ. Failed. For Sonnet, yeah, let's stop. Failed. Gemini. We could wait for some time, for some more time. And let's make sure that DeepSeek is the one we actually run. Yeah, success for the first part, and 2242, I think. Yeah, isn't correct, but close, Okay, Gemini, sorry, but it's failed result for you. Okay, so here are the results for the day 22 of Advent of Code 2024. Only O1 successfully solved the second problem, but almost all the models were able to solve the first one except for GPT-4o for some reason. Okay, so we are ready to move to the day 23, and also there are 2 more days left until the very end of the Advent of Code challenge. And after that, I'm going to produce a comparison table between all these models, how they solved all these tasks. Okay, let's firstly commit our results for the day. Sync changes and yay. Okay, so I'll see you on the next one, which is apparently no one is watching, so I'm just talking to myself. But if anyone is watching this in a recording, you'll be able to find the next day on my channel. Just go into the live stream section, and yeah, there it will be.